We are switching to English because Michał from Scalac will tell us how to normalize your state. Put your hands together for Michał.
So yeah, that was like a good beginning of the presentation. Can you hear me well? No? And now? Oh, okay. Yeah, sorry. So yeah, today we'll be talking about. Yeah, it's working. Seems to work. Yeah, thanks. Yeah, so today we will talk about normalizing the state. So we will talk about what is it, how you can implement it, and how greatly it can improve your state quality, and therefore like your op quality. So yeah. So I'm Michał Klim. I'm front-end developer for like 5 years now. At the beginning, I worked mostly with like branded WordPress sites, doing some styling, mostly focusing on animations and so on. And later on, I entered more into JS world and React, and basically React ecosystem like Redux and so on and so on. And I loved it, and I stayed there. And yes, so what's going on with state normalization? It's like really interesting subject for me because at the beginning of my journey with React, I started writing application not only in React but also in Redux. And the story was that it's a common story. The company wanted me to write this application in React. I didn't know it, and the deadline was tight. So yeah, great. I used Redux, so I started to quickly like scanning the Redux documentation, and yeah, there was this small chapter about normalizing, but yeah, I didn't use it actually then. Because basically there was no much information about it in Redux documentation. There was not much information about it anywhere basically, and yeah, and I didn't need it actually to write the Redux application. So yeah, I went basically YOLO. So yeah, tried to make that joke about testing. So. Yeah, and yeah, I think it's a good time to ask you guys, do you normalize your state on a daily basis? Who normalizes the state on a daily basis? One person. Yeah, I think so, yeah. But that's actually great. And sorry? So you don't normalize your state. So we'll get there. So how many of you guys even heard about normalizing the state? Oh, yeah, okay. So 2%, I guess. So actually that's great because my goal of the goal of this presentation is actually to show you what it is to normalize state, and actually convince you to do it, because it will take you a bit more work, but it's worth it. So I prepared this really professional graph, and yeah, as you can see, I was aware about normalization at the beginning of my journey with React, as I mentioned. And as you know, I didn't do it for the first time, and I didn't do it later on. Even when I felt quite comfortable with Redux and state management and so on and so on. The reason for that is basically, yeah, once again, there was not so much information about it anywhere, and nobody was writing about it, nobody was talking about it, and I didn't see this approach in any project I was. With Redux or without, with Mobx or with different approaches to state management. So I thought to myself, okay, that's maybe the concept that that didn't stick around actually in a community, so why bother? So I wasn't bothering for all this time, let's say, but in the back of my head I always knew there is something wrong with how I how I manage my state, basically. So it wasn't predictable after all. Basically, if client said something, oh, you know, we have this small change in the business logic, I was like terrified. It was like really bad. So my state wasn't feature-proof, basically. Wasn't ready for refactoring. Wasn't ready for changes. So yeah, and after that I get around a bit of normalization, but still didn't do it. And until recently, I said to myself, okay, let's try it. I have some spare time. Let's try it. Let's try it in a real application. And yeah, as you can see, my normalization awareness went up drastically. So because it's a great concept. It's relatively easy, and the benefits you are getting from it are like great. Okay, so by now you should be aware that I think the state normalization is great, but what it actually means to normalize your state. So there are plenty of different definitions of normalization. And the one that we will be using are related to the database normalization. So basically, we'll take some concept from databases and apply it to our state management. So as you can see, there are two main principles taken from Tihupedia. There is no redundancy of data. So all data is stored in one place, and data dependencies are logical, so all related data items are in one place, and that's really important for us. So let's consider like typical common product data. So we are getting this collection of products. So we have this product, like let's say it's I don't know, iPhone 6 or something like this. And iPhone 6 have variants. We see there are two variants here. So variant is something like, I don't know, it's iPhone 6 32 gigabytes and iPhone 6 64 gigabytes. And variants have also attributes. So we need this data to actually show, I don't know, like color picker to the user or something like that. So at this point, we could take this data and make like a products reducer and put it there, and everything should be fine. But not actually. So basically, updating the data will be hard. Deleting the data will be hard. Even getting the data at some point could be hard. So also, data structure is complicated. It's hard to read and reason about. So this is only the small subset of data. It's one product with two variants. But in a real world, this data could be much bigger. So it's hard to see what are the constraints here and what entities are there, actually. So some data is repeated. Even in this small example, we see that we have repeated attributes. So we have attribute score red. And here we also have attribute score red. That's like a bad thing if we keep this in our state, because when we later on want to update the data, like change the name of the attribute or something like that, we'll have to make sure that we will update it anywhere, not only in one place but in every occurrence. It could be like really simple, or it could be like really difficult to do. And yeah, probably corresponding reducer logic could be complicated since we are dealing with nested data. So even changing like one property of a nested project could bring like a lot of pain to us. Basically, let's see how it could look if we want to change name of the attributes to uppercase. So yeah, basically we have this action at product, and then we have to map over the variance. We have to map over every attribute and then change the name. So it doesn't look that scary, basically, but that's like a really simple case, and probably you could make it with reduce, not with two maps, and so on, so on, so on. But it's still bad, and it has like badly influence on our architecture, because now product's reducer has to keep logic that only concerns the attributes entity. The entity is really important word here. So let's try to normalize this data. So first thing we have to consider is what types of data, what entities are there. And as we look at it, we already talked about it, we have those three entities. So we have products, we have variants, and we have attributes. And yeah, let's normalize them. Let's move all of them in a separate tables. Let's pull them up and move them to separate tables. And yeah, automatically our state is normalized. So basically what we done here, we make for each entity we make different table. So we call it by IDs, and we change our collections to objects. So every item in an entity is now a property of an object. So this approach is giving us a lot of benefits. It looks strange, but please bear with me. So as you look now on the data, it's already simple. It's flatter, and we can clearly see the distinction between entities. We see how many entities we have and what are the relations between them. And yeah, so the structure of the state is clearer. So the reducer, corresponding reducer logic will be probably simpler. So because we don't deal with nested data anymore. We have no repetition of data, so as you can see, the attribute score red is no longer repeated. We store only one occurrence of it. Even obtaining the data is now easier, because we have to provide only the entity type and entity ID. We don't have to filter, map over it. If we have an ID, we can obtain it. And also, at this point, we have some performance gain, most probably. Since we decoupled those entities, and when we will be updating the data, like only for attributes, we are updating the smaller subset of data. So basically, all the components that are dependent of this data, for example, products, won't be re-rendered. Only those components that depend on attributes data will be re-rendered. So there is this great performance gain. And also we have more flexibility. So by pulling this entities up in a state tree, and by treating them equally, we are now we are ready now for more changes. So like imagine the query if your client will say to you, okay, let me show I want to have page with all attributes, all possible attributes. I don't know why, but that could be the case. Okay, so you already see how can normalized state look like, but let's actually do it. So that's our entry point for normalization, and we'll be talking about normalization in the context of Redux, since it's I think most well-known state management tool. So that's our entry point, and basically it's really simple. It's just reducer that combines other reducer, and if you thinking about combine reducers, we'll be using it a lot, and it's like great tool to decouple our state logic. So most often there is only one combine reducers function in an application when we create the store, when we creating the root store. But yeah, now let's use it on a daily in every reducer. So yeah, we are pulling all our different reducers into the entities reducer, and that also giving us the more flexibility, because when app grows, we can add more and more entities, and we don't have to think about how we have to structure the data. Okay, so that's the products reducer. It's quite simple at this point. So basically, we are adding the product, and we are adding new property in an object. And the key of this property is product ID. The next thing we are doing is basically spreading out the whole product object. We also will have the ID inside of it. And we're changing the variance collection to only store the variance IDs and not all the project. So yeah, and one thing to notice here, we are also using the combine reducers function here, and we are making this table by IDs. It's for now it doesn't make much sense, but we are trying to predict the app will grow. It will change, so we can be able to add another tables, like we can store search IDs. If you have like if you have the search functionality in your application, we can store it here, for example. Most common case is to have this all IDs table that only stores the IDs of products and nothing else, to keep the order of the items and to like quickly have access to all the items and be able to iterate over them. So that's our variance reducer, and yeah, we're doing basically the same thing, but since we know that in every product variance will be collection, we actually changing the collection into object. We are doing it by using reduce function, and yeah, we are doing the same thing. Basically, we are changing attributes collection to store only the IDs. And yeah, the attributes reducer. All of the really similar logic, all of the same, but yeah, we have to use flat map here, because we have to take all attributes from all variants. So at this point, it's possible that we have some duplicates inside this collection. But if we are changing it to the object, we don't have to worry about the duplicates. So if the property with that key is already there, it will be overwritten. So yeah, basically we are now normalizing our state, and we can store it. But I know what you guys are probably thinking. So yeah, there is no way I will do so much work just to store the data. So, and yeah, I completely understand you, but yeah, so if you get used to it, it will get really easy. That's like the first argument. Then the benefits are like really important. So you have this more explicit, greater architecture. You are ready for app refactoring or changes in the business logic, and you can always write some kind of helpers to help you that, or use the existing ones. So we have this great Normalized library, and it can do a lot of heavy lifting for us. That's a funny thing, because Normalized library was initially developed by Dan Abramov, who also developed Redux, basically. So nowadays it's maintained by Paul Armstrong, and it was completely rewritten, but we can clearly see the connection in Redux and normalizing the state. So even if it's not treated equally as other chapters in Redux documentation, it's still quite it could be quite relevant knowledge. But normalize library. So basically we importing the data. So the data is our well-known collection of products, and we defining three entities. So we have attributes entity, we have variance entity. We are saying also that inside the variance entity there is nested entity also, and we are telling the normalized library that. So we say, okay, attributes will have entity attribute, and it will be a collection. We are doing same thing with product entity, and basically we are defining our schema here. So at the end we just use the normalize function, and once again automatically we have the normalized state with only, let me see, 14 lines of code. And yeah, that's basically it. So once again, let's see our reducers, how those reducers could look like now. So that's the products reducer. Basically we are spreading the entities products there. That's also the variance reducer. We are doing basically the same thing, and that's attributes reducer. So as you can see, we really simplified the logic. We don't have to deal with it, and since we are basically doing the same thing in all of those three reducers, we can even further optimize it. So we can make this higher order reducer, or we can make this factory reducer, or something like that. So yeah, basically I hope I convince you a bit to try normalizing your state. It can be terrified at the beginning. It can be it can seem useless actually, but it's giving us a lot of benefits, and our state architecture is more explicit, and it's not always about writing less code, and most often it's about writing more explicit code. And some useful links, and I will share this presentation later on. Okay, thank you guys. Dobra, postaram się zapytać. Pytania mogą też być po polsku? Chyba? Mogą być i po polsku, i po angielsku. O. Yeah, so actually, without normalize, I was mentioning about that the most like common pattern is to keep all IDs table also, just to keep the order of the items. So the all IDs table will be only the array of IDs, and then we can use it to iterate over this object. So yeah, that's it. Anybody else? Okay, thank you.